Hello, this recording is about the third classical technique in machine learning using decision trees. Decision trees are versatile machine learning algorithms that can perform both classification and regression tasks. They are also very powerful algorithms and are capable of fitting complex datasets. Here I have an example. We're going to use the iris dataset. Here we import the decision tree classifier class from the tree group of scikit-learn. We first load the dataset. We're going to use only two features, the petal length and width. But now this is multi-class problem. The target has three classes, 0, 1, and 2. We create a model using this class, and this is an important parameter, which is the maximum depth of the tree. We specify 2. Then we do training as usual. The following will explain what max depth equals 2 means. Here we can visualize the created decision tree. This tree was drawn using the export graph viz graph visualization function. We give it the model. We give it the output file where this graph will be stored. The feature names are the last two features, and we also give it the class names. Rounded shapes and with filled. You see how they are filled with colors. Now, the colored nodes are leaves, and the white ones are where decisions are made. This plot shows the 150 instances. We have three classes, yellow, blue, green, and two features, petal length and petal width. Now the algorithm has decided that it's best to make the first decision based on the petal length feature. This is the petal length feature. And the decision is if it is less than or equal 2.45, then go to this region. This is the decision. And if it is false, then go to this region. Now, the algorithm found that the purity is perfect here, so it can classify all nodes in this region as class setosa. For the false case, it has decided that it's best to take the second feature and the decision threshold at 1.75. If the petal width is less than 1.75, then the purity of blue is high and the impurity is low. It classifies all points in this region as versicolor iris. If it is false, then it classifies them as virginica. Notice that this is two levels, means that there are two levels of decisions, and we can give it 3, and with 3 we'll get more refined decisions. Here, 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 here. Decision trees can overfit the data. There are many ways to regularize decision trees using the regularization hyperparameters. These are the most important ones. Max depth, usually it is none. In the previous example, we specified 2. Minimum samples split 2. The tree is split even if it has only 2 samples. Minimum samples leaf a leaf can have only one sample. Minimum weight fraction leaf, the same as minimum sample leaf, but in a fraction ratio of the total samples. Maximum features, the maximum number of features that are considered in a certain node, and the maximum leaf nodes is the total number of leaves in a tree. Decision trees can also do regression. You can import decision tree regressor. Here we create a model from this class. The maximum depth we are specifying here is 2. X and Y here are simple. We have one feature and we want to predict the response Y. It looks that this is a quadratic function with the maximum depth of 2 levels. It splits it for the first time here and here and here in the second level. The regressor gives a level. So everything is in this region is this level, everything in this region is this level. When you increase the depth, you can have more refined model. And this is the end of this recording.